Welcome to Digital Sculptor's tutorial series. Today we will look at Export IGES Addon for Blender. The add-on exports the limit surfaces of meshes with subdivision modifier. The limit surfaces are defined as bicubic B-spline surfaces, which can be further modified in a 3D CAD program such as FreeCAD, Rhino 3D, etc. For this tutorial, we will use Rhino 3D as the CAD package. Please be reminded that this add-on is not meant to transfer mesh data as it is. Please use a suitable format such as STL, OBJ, etc. to transfer such data to a CAD program. Many CAD programs can convert quad-dominant meshes to subdivision surfaces. But they all differ slightly in their implementation of creating the limit surfaces, especially with regards to vertex and edge creases. Also, most CAD programs that has subdivision capability can import meshes only in OBJ format. The OBJ format currently does not support edge or vertex creases. The Export IGES add-on solves this problem by exporting the shape of the subdivision limit surface in Blender as it is, through the IGES format, which is a neutral format. The subdivision scheme is based on Catmull-Clark algorithm and uses the Open Subdivision API from Pixar. Please be reminded that the limit surfaces is set to retain all corners. The add-on is available for Windows, Mac and Linux. The link to the documentation and download information is in the description below. Just like other Blender add-ons, it is a zip file. Do not unzip the file prior to installation. To install the add-on, open Blender, go to Edit, Preferences, Add-on. Click on the Install button and point to the downloaded file. The add-on will be installed. The add-on is now enabled by adding a check mark. The Documentation button opens the online documentation. Close Preferences. The add-on is now installed under File, Export, Export IGES. The options in the Export IGES dialog box are as follows. Selected Only, exports only the selected objects. Batch Mode, exports the objects as separate IGES files. The name of the files will be in the format name_objectname.igs. This is very useful in assembling the data in a CAD program as different parts. Refinement Level. The refinement level controls the refinement of the limit surface at vertices of valence 3, 5 or more. It also defines how n-gons are subdivided. By default the value is set to 3. If the model contains only quads and do not have any vertices with valence 3, 5, or higher, then this value can be set to 1. Up, this option along with the forward option can set the axis while exporting. Blender by default uses the Z-up scheme. Apply modifiers. All modifiers are applied, except the subdivision modifier. By default this is switched on. Modeling tips. Please read the modeling tips from Pixar to create light and clean models, with good topology. The golden rules are: use fewer spans. Avoid high valence vertices. Also described are ways to achieve the following. Edge loop transitions. Where to place n-gons. How to use semi-sharp creases instead of bevels to reduce the complexity of the model. The link is in the description below. We will try to export a model in Blender using various options. We will then import the file into Rhino 3D and compare the results. Using the default option. Open the file to be exported. Select the objects and click on File, Export, Export IGES. Keep the default options. Click on Export IGES and give a file name. Using lower refinement level. This time let us reduce the refinement level to 2. And save the file. Using the lowest refinement level. Reduce the refinement level to 1 and save the file. Next we shall use the batch mode. This time enable batch mode and click Export IGES. Give a name. All the objects are saved as separate objects in the same folder. The size comparison shows that the file with the refinement level 3 is the largest and the one with refinement level 1 is the smallest. Now let us open these files in Rhino 3D and compare the difference. In the Rhino window, all the 3 files have been inserted as separate groups. The first thing to point out is that in most areas that were made using quads and vertices with valence 4 are identical. Only the areas that had triangles and n-gons are different. The one with refinement level 3 is the most dense and the one with refinement level 1 is the least dense. A quick surface analysis using the zebra pattern indicates that all 3 variants have good visual continuity. However, if we check the edge continuity, we notice that the one with higher refinement has very high continuity. The parts that were saved during the batch export can now be inserted into the assembly. In this example, the parts are inserted as groups, so that they can be selected separately for further modifications. This is the end of this tutorial. Please leave your suggestions and comments below. Thank you for watching.